All right, guys. Sorry, this is Regents Chem. So I'm going to go over the free response questions we didn't get to yesterday in our Google Meet. So I'll go over number 2, 4, and 5. I'm going to do one at a time. I feel like that's more efficient, maybe. I don't know. But here we go. So for number 2, we'll go orange. Number 2, this was the microalgae for fuel production, talking about how they can get oil from the microalgae. They can even put it in wastewater. The top couple inches, talking about at the end of the article growing it on rooftops. But basically, 50% of the algae is oil. 50% oil. And then it has a chart, gallons of oil per acre per year. So if we look at number 2A, all right, number 2A, calculate the number of acres required to produce 1,000. So we want 1,000 gallons of oil per year, right? So, and A1 was the algae and A2 is the soybean. So in the chart, it says gallons of oil per acre per year. So gallons of oil per acre per year. Sorry, I'm trying to squeeze this in. And for the micro algae, it is 10,000. And then for soybeans, it says 50. 50, right. So it's 10,000 gallons of oil per acre per year, and then 50 gallons of oil per acre per year, right? So we want to know for AI, we want to know the number of acres required to produce 1,000 gallons, right? So how many acres do we need to produce 1,000 gallons of microalgae, right? So I'll come back to that. So if we know that microalgae produces 10,000 gallons of oil in 1 acre, right? Then we want to know how many acres we need to get 1,000 gallons. So just proportion makes more sense for me in this case than the dimensional analysis, but you could also do it that way. Again, we got 10,000 gallons of oil in 1 acre. So how many acres do we need for 1,000? So X is going to equal 1,000 divided by 10,000, right? So, whoop, sorry guys. I just lost my thing here. I like to stay with you here. All right. So, so that's 0.1 acres, right? I could have done that math without the calculator, but 0.1 acres, right? So that's how we do number 2 AI. Okay. Now II. So now we want to know, how do we get 1,000 gallons of oil from soybeans? So we know there's 50 gallons of oil in 1 acre of soybeans. So we want to know, how do we get 1,000 gallons, right? How many acres? All right, so if 1 acre produces 50, how many acres produce 1,000? So for soybeans, it is just 1,000 divided by 50. So X equals 20 acres, right? Which makes sense, because if you're getting 10,000 per acre, you only need 0.1. But if you're getting 50 per acre, you need a lot more. So that's 20. So there we go. So that's 2A. Let's go to 2B now. I should have just done that. Save time. All right. So number 2B. All right. So what's 2B asking us? 2B. Describe 2 environmental advantages that biodiesel production from microalgae offers over biodiesel production from other crops listed on the table. So what's an advantage of microalgae over corn, soybeans, safflower, sunflower, rapeseed, and oil palm, right? So what's 2 advantages? Well, the first thing I thought of is land use, right? You need much less land for microalgae than you do any of the other ones because they're crops that you have to grow. So okay, right, less land use for the microalgae. All right, so some of this I'm just going to kind of say out loud if you're watching this. So I'm, just to save time, I'm not going to write every little thing. But remember, on the test, you have to spell it out. So you would have to write less land use for microalgae. The other sources are crops that require large amounts of land, right? So that you would have to write all that out. And we need 2, right? So another one here. Oops. So less land use, also less damage to the land, right? So if you're growing crops, the soybeans or corn, whatever, so there's going to be less tilling, less erosion, less runoff, right? Because we're not damaging or, removing vegetation to grow crops. So let's see, what else did I think of here? So there's two. Another one would be less fertilizer and pesticide use, right? Because you're not growing crops, right? So you don't need those. Let's see, and we're going to save water because there's less irrigation needed because you're not growing crops, right? So, okay. So aquifers would not be depleted. All right. So there's 2B. All right. Number 2C. What's C asking about here? So 2C. Let's see. Explain why burning biodiesel fuel has a different impact on atmospheric CO2 than burning fossil fuels. My first thought was because it's modern carbon, right? So biofuels is considered modern carbon, right? So it was just recently sequestered, right? Modern carbon recently sequestered. So it does not increase the carbon in the atmosphere. Because remember, think of respiration and photosynthesis. I mean, plants are doing this every day, right? So if you take a plant and you burn it, or you let it do its thing and release the CO2 when it's respirating, it's not a whole lot of difference because it hasn't been buried in the ground for millions of years, right? Even if the plant or whatever it is, is decayed and it has died, and it's still recent, right? In human time frame, it's recent. Modern carbon, so that's why biofuels are better, as opposed to, remember, you have to say the other part. Always explain everything. Fossil fuels, when they're burned, increase carbon in the atmosphere due to the carbon being trapped in the ground. Sorry, that's trapped. That's really terrible. For millions of years. Hundreds of millions of years. So that carbon's taken out of circulation, right? The carbon in plants and biofuels, it's recently been in the carbon cycle. This one has not, right? So there's your answer to part C. All right. Let's see now. Let's switch up the color. Let's go with this color here. All right. Where are we? Part D, number 2D. All right. Discuss 2 benefits other than those related to atmospheric impacts of increased reliance on biofuels over the next 50 years. So 2 benefits other than atmospheric impacts. So let's see. The first thing I thought of is biofuels are renewable. I mean, they can be, right? They can be. And again, you have to explain it. Biofuels are renewable because you can regrow, let's say, corn. So you burn the corn and then you can grow more corn, right? So you could elaborate that. And then you could also say, fossil fuels are not. Fossil fuels are not renewable. Let's see. Let's see. What's another on 2 advantages here? Let's say increase in jobs, right? So if you're going to have a whole lot of biofuel, like let's say corn or even the algae, you need jobs to grow the fuel, right? So increase in agriculture. Let's see, what else? Less, let's see, how would I word this here? Less an environmental damage due to transporting fossil fuels, right? Or transporting or harvesting, right? So fracking to get natural gas, pipelines or tankers that could leak oil. So you would have to elaborate on that. A decrease in dependency. I don't know how to spell dependency. Decrease in dependency on fossil fuels from other countries, right? So if we could grow all our biofuel here, we would have less dependency on fossil fuels. So you have to really explain that and discuss it. You can't just say decrease in dependency on fossil fuels. Why? Because we could grow our own biofuels. We wouldn't rely on foreign oil, let's say. All right, so there's 2D. And let's see, is there an E? I think there is. 2E. Every time. It gets me every time. 2E, what are we asking for here? Describe 2 economic or societal problems associated with producing fuel from corn. My first thought is the price of corn will skyrocket. So that was definitely my first thought. Price corn increases because we're going to be growing a lot more of it. Because we're using it not just for food, but also for energy. So again, you have to explain all that. Along with that is there might be a decrease in food, right? Specifically corn. If we're going to use corn exclusively or soybeans for energy, we're going to have less of it available for food. So that could be a problem. We're going to increase agricultural land use, which would decrease land use for other reasons. And what could that be? Well, it could just be aesthetic value, right? Just leave the land undisturbed. It could be, you want to build a town or, recreation, areas, parks, but you can't use that because you got to use it all up for corn and soybeans, for example. Let's see here. Maybe a decrease in water supply, right? Because now you have to irrigate all these fields. You're going to be growing these crops for energy, right? Again, you have to explain all that, but I'm trying to go a little quick here because this is already long enough. So that's it. That's number 2. So hopefully you're watching this. All right, here we go.